All right, guys, today we're going to talk in a few minutes about whether a function is continuous, and we're going to talk about end behavior. We talked a little bit about end behavior yesterday from a polynomial's degree. We just talked about if the highest exponent was even, both ends would go up or down. And if it was odd, one end would go either way. So today we're going to get into that a little further. And then we're going to talk about how you write an end behavior statement. Okay. This is blurry to my old eyes, but basically this is just the definitions we came up with yesterday. An even function means it has y-axis symmetry. Is this sounding familiar? We talked about symmetry with the y, symmetry with the x, and origin symmetry. Okay. Origin symmetry meant you could rotate it 180 degrees. And y-axis symmetry meant you could fold it in half right here and both halves would match up, unlike my squiggly one right there. Okay. If it had y-axis symmetry, it was called an even function. You have to tie those two ideas together in your head because it's going to ask, is it even or odd? And you need to know what that means. An odd function was one that had origin symmetry, okay? If it had x-axis symmetry, like this, it failed the vertical line test, so it wasn't even a function, okay? So I am going to call on some people, and to try to make this not scary, I'm just going to give you a word and you pick whichever one you're pretty confident this works for, okay? I know they're not very big. Ben, can you pick one that you think has origin symmetry? Number 5, what do you think, guys? Could we turn that 180 degrees and it'll be the same? Yes, this one is odd or origin symmetry, okay? How about another origin symmetry? Cheyenne, can you pick one? Upside down, that would look different. It does have some kind of symmetry. If you folded it here, then the two halves would match up. So that's called what? What is that red line I drew in? The y-axis symmetry, which makes it an even function. Antoine, did you have one you wanted to talk about? 8 is odd? Yeah, it's basically the same as 5. Anybody else? Elo? 11, would that work if we turned it 180, guys? Yep. 6, yep. Anybody else? I see a couple more, actually. 9, everybody good that that's just kind of like some of these other ones, it just happens to be pointy. 3 would work. Actually, I think 4 would work as well. Now, are all the other ones even? No, a bunch of them are neither. Can anybody pick one that is even? Has y-axis symmetry. 12 looks good, right? We can fold that here. This one is even, this one is even. Okay, several of these other ones are not functions. Can you tell me not a function? Fails vertical line test? This one, okay. And then what about the leftovers? This just doesn't have symmetry with either the x or y, right? So that's not even nor odd, which is true of all the ones I wrote not by. What about this number 15? Doesn't have any symmetry, so it's not even or odd. Okay. Does that help some of you with yesterday's stuff? Can anybody remember the test for whether something is odd or even by looking at it? If it's a polynomial, you can look at all the exponent powers, but otherwise the test for even is y-axis symmetry, so you could take any point and change the x and it should be the same. And odd is origin symmetry, so if you put in the opposite signs on, on both, it should also be a point, but that's gross. Most of us would type it in the calculator, yes? Okay, I'm not gonna take a lot of time on this slide, but can anybody look and think of one that they think might be even, just by looking at it? 45, okay. This graph would be like this. Good choice. That one's even. 49 is also even. It's just got a different stretch, okay. Somebody said 48. I would have probably guessed 48 because it has, but does anybody remember what happens if you FOIL that out? You get x squared minus 4x's and a plus 4. Because this is an exponent power of 1, it is also a parabola that's been shifted to the right too, so it's actually neither. Okay, square root graph looks like this. That would be neither. This might be odd. Do you see the exponent powers are 3 and this would be 1? So that one would be odd. I honestly don't know what that looks like, 47, so I'd have to graph it and think about it. All right, enough review. Today we're going to talk about continuity and then we're going to talk about end behavior. End behavior in particular approaches the idea of a limit, but I want to save the real definition of a limit for a calculus class. Okay. A graph is said to be continuous if there are no breaks or holes in the graph. If there are breaks or holes in the graph, it is considered to be discontinuous. Too many letters. Too many vowels. All right. There are 3 types of discontinuity. I am not going to ask you this on a quiz, but it is asked on the homework since you'll have your notes in front of you. A function has an infinite discontinuity if it has like a vertical asymptote. It has a jump discontinuity, mostly in piecewise functions where there's 2 different rules and it jumps from one spot to the other. And it has what's called a removable discontinuity or a hole, also called a point discontinuity, if it has this little open circle somewhere, okay? In other words, it's continuous on both sides, but it has a hole there, okay? So this one would be a infinite discontinuity. I'm just going to write that because if I try to fit discontinuity in there, it's not going to work. This one is called a jump discontinuity. It says over here types of discontinuity, so I'll go with that. And this one is called a removable discontinuity. But you could also call it a point discontinuity, or we could literally call it a hole. All right, so these are very visual things to worry about. At least the first few we're going to go over here. I don't know if you have all of these or not, so stick with me, write down the ones you have, but otherwise we'll just look up here. In Delta Math, when you do this little assignment, it says, I don't even think it asks about the type, but it asks where the discontinuity is. When it asks for the location of the discontinuity, it wants the x values, okay? Like many, many things we're going to do in the coming days, it wants the domain the x value where it is discontinuous. So this is discontinuous over here at, can anybody count that for me? X equals, is it -6? -5? Okay. So in Delta Math, I think you just type -5, enter in the little box, and it would tell you that's where it's discontinuous. And what is this one? Anybody remember which one that would be? Yep, that one is a jump discontinuity. Is this discontinuous? Does it have any holes or breaks or gaps? Nope, got arrows on both ends, so this is continuous. Can I just write that? What about this guy? If I'm going left to right along this graph, I have to do it has an asymptote in here. That's called an infinite discontinuity. And again, I'm not going to quiz you on what they're called. You might need to know that for calc, but you don't need to know that for me. But where is that at? What x value? Is it at 1? Okay. So it looks like x equals 1 is where it is discontinuous. Do you have a couple more of these, or do I just have extras? You don't have these? You do? Okay. What do you think? Left to right, this one looks continuous. Left to right, this looks continuous except for one tiny little, you could call it a point discontinuity or a hole. And where does that occur? X equals, is it -3? Is it -3? These are so hard for me to see. Okay, I think this guy's got 2. Do you see what I'm talking about? It's got an infinite discontinuity or an asymptote at x equals, is that 2 maybe? And then a couple more to the right, so maybe at x equals 4, I'm just going to call it a hole. So I think in Delta Math, it just gives you a picture and it says where are the discontinuities, and you have to put in the x values. Easy peasy. Okay. If you were given something like this, this goes more towards what I talked about the other day with domain restrictions. This is a polynomial function. It is a parabola because it has an x squared. So if I put a 4 in it, I get out 16 plus 20, 39 or something. Bottom line, does a plain old parabola or a polynomial with no denominator and no radical have any restrictions? No, so this is continuous. Okay, you could graph it on your calculator. They're asking specifically about the point 4, but the bottom line is the entire parabola is one thing, so it would be continuous at any point. All right. This particular one is weird. The top says this. The bottom factors, x plus 1 and x minus 1. Does anybody remember how we did domain restrictions? What 2 things can x never equal according to this? Yes, you can't have a 0 in the denominator. Does that sound familiar? So x cannot be -1 or +1. All right, they ask is what's happening out at 11. Well, if you put an 11 in here, you get 22 over 120, I think, which is fine. So it's, yes, it's continuous out at 11. At 1, if you put a 1 in there, you would get 2 over 0. Is that okay? No, so it's discontinuous, okay? If you put a -1, you would get a -2 over -1 squared is 1 minus 1 is 0. So it's also discontinuous at -1. All right, this is an idea that we're going to do another day. We're going to spend a lot of time on these. These are piecewise functions, but it's asking about 2. Does anybody notice where 2 comes in? 2 is where it switches from this rule to this rule. Everybody see that? Okay. So we're going to put 2 into both rules, I'm just giving you an intro to this idea. We're going to put the 2 into both rules and see if it's at the same point. In other words, does this rule end at exactly the same point as that other rule starts? So if I put a 2 into the, I know it says greater than 2, but it would have an open circle. When you put a 2 in here, which would give me out 2 times 2 plus 1 is 5. Okay. The bottom rule, 2 minus 1 is what? I put a 2 into that bottom rule, I get out 1. So it's clearly jumping. It's not continuous. Again, not something I'm going to put on this quiz, but eventually when we do piecewise functions, because the rule changed at 2, if you put a 2 into each, if it's not coming out the same point, then it's doing some kind of a jump. All right. So there's some Delta Math practice on that, and maybe a little bit on the worksheet. I don't think there is on the worksheet. Okay. The second part of the assignment is on end behavior. End behavior is how you describe what a function does as x increases without bound. In other words, x gets really, really big, which means off to the far right. Or as x decreases without bound, gets more and more and more negative, or on the far left. Now, our textbook that we're not using really uses limits to describe this, but we're going to stay away from limits until calculus. So I'm going to skip the rest of this slide. If you have any room that you can write this down, this will help some of you who really struggle with end behavior. What axis is this, guys? Going across. Please pay close attention here. This is x. And as we go this way, the x values are getting really, really what? Really, really big. If we continued far off to the right, would they be positive or negative? So we're going to write infinity, okay? Now, x gets really big means the right end, the right side, right end, okay? Just the word right is fine. As you go off to the right, x approaches infinity. Now, if x is going this way, so x is approaching what as it goes off that way? Out here would be negative infinity. So the arrow for approaches always goes left to right. So this reads x approaches negative infinity. But what direction is that? When I write x approaches negative infinity, you're telling me I'm going left. That you have to be able to translate. This is like a foreign language. This is math language. X towards negative infinity means left. X towards positive infinity, the x-axis getting big, means to the right. What's the difference then for y? When I say y is going up, what am I going to use there? Yes, up on the y-axis would be positive infinity, and it's a y, not an x, because the y-axis points up. It will also often be written as this. F of x means the same thing as y. All right, so what are the ones for down? Is down an x or a y? Y-axis is pointing down, and it would be getting more and more negative. Either one, f of x or y, is getting more and more negative. Everybody can translate those 4 words? Symbols, words, back and forth. Okay, so on our notes, it says left end behavior, as x becomes more and more negative, we write f of x, let's see. Oh, we don't write anything in here. We either write a positive or negative infinity. This is saying y approaches what as x approaches, and this is the left. Okay, right end behavior, we write f of x approaches, or y is getting closer to what, as x approaches positive infinity, means as we go further to the right. The f of x values may either approach positive or negative infinity or a specific value. All right, so what does this mean? We just wrote this. Anybody tell me what that translates into? You awake, awake, awake. People are sleeping. F of x means y, negative infinity means down. F of x approaches infinity means y approaches infinity, so it means up. Okay, x approaches negative infinity. The x-axis goes left for negative infinity and right for positive infinity. Right here. Everybody okay? So now we have to be able to use those words to describe what a graph is doing, not just the axes. So for this particular graph, as I go further and further to the left on this graph, what is the end behavior doing? It's going up, yes? So the left is up. How do I write that? Now, they put the x at the end, so you can fill it in any order you want. Where would left go? That's an x value, right? Correct, not right. Left is, x is approaching negative infinity. This graph is going up, which means y is approaching infinity. Can anybody tell me the other end of the graph? As I go further and further to the right, what's happening? Okay, if I say right, I say x approaches infinity. And what is the y value doing on the right? The y value is getting more and more negative. Now, how many different options do we have, guys? Left is either going up or down, right? And the right is either going up or down. So in general, unless it's approaching a particular value, there's only 4 choices. Therefore, in Delta Math, these questions are multiple choice. You just have to read them very carefully and figure out which one is saying what you want it to say. All right. So just tell me in words real fast. What is this graph doing? Both ends are going up. Everybody good? Left and right are going up. So if I put this here, what did I just write? Did I write left, right, up, or down? Because I wrote it on an X blank with a negative, I wrote left, and you want to say it's going up. So you say positive infinity for the Y. Make sure, sometimes, like Delta Math might do it in this order. Different teachers, different texts, different softwares do the X first and then the Y. Some do the Y first and then the X. You just got to know that X always means either left or right, okay? So what's the bottom one? As X approaches, what do I not have yet? Positive infinity, it's still going up. Everybody good? So your X's have to be left and right, but your Y's can be the same because they could be both ends up. What about this next one? Both ends are going down. So if we started with our f of x for y, it is going down towards negative infinity when x is, which one do you want to put first? Should we say left first? Negative infinity is left. X approaches positive infinity is right. And on the right, it is also going down. How many of you are totally lost? A little bit? Nobody? You're following the vocab? Okay. This graph can be confusing, but remember, end behavior means far off on the end. So as I continue to go towards the left, what is this one doing? It's going down, even though it's got a discontinuity. On the far right, it's going up, right? Correct? Okay, so if I want to say left first, that would be x approaches negative infinity. And on the left, the y value is doing what? I'm going to be lazy and use y instead of f of x. On the left, the y value was going towards negative infinity, which is down. Somebody give me the other one. Can you do the y first? Y approaches infinity because it's going up as x goes towards the infinity again, which means right. All right. The other possibility that there isn't much delta math on this, but you have a little bit of practice on a worksheet. As x moves towards positive infinity or negative infinity, it is also possible for the function to be approaching a certain set value. So this has a horizontal asymptote. And as you go further and further to the left, okay, left would be this. What is the graph getting closer and closer to? Can you tell what y value that is down there? -1. Now, eventually in calc, you might have to say it's approaching -1 from the bottom instead of from the top, but we're not going to worry about that. But the right-hand side is also getting closer and closer to what? -1. Right-hand side would be a positive infinity for x, and also getting close to -1. Because the x values, the y values are approaching that y equals -1 asymptote. So a couple more. What is this one approaching as you go to the left or the right? Do you not have this one? Do you? Yes? On mine or on your paper, or both? I think it's just staying really close to the x-axis. Does that seem okay? The x-axis is named what, though? Y equals 0, so the y values, so y is approaching 0 both times. How do I write whether I'm going left? X approaches -infinity, or right, which would be, x approaches positive infinity. And my commas should probably be the word as. I don't remember how delta math does it. Okay, this one doesn't have both ends approaching the same thing. The left end is approaching what? It's going up forever. How do I write that? Okay, can anybody give me the whole line? I don't really care if you start with x or y. Is that correct? Y is going up as x goes to the -infinity would be left. Okay? What is y approaching as x goes to the right? As I go to the right, it seems to be stuck right about, anybody tell what that is? Is it -5 or -6? Okay, thanks. All right, last one, I think. Number 12, what is both ends approaching? So we go off to the left, it seems stuck at what? And off to the right, it also seems stuck. Can anybody tell what that is? There's the origin. 1, 2-ish? 2? Okay, so y approaches 2 as x goes left. Sorry, I totally scrunched that in there. And y approaches 2 as x goes right. Sorry, that's a hot mess. How are we doing? So on 3B, there's a few more examples. I'm gonna call on a people. What if people would like to do this one? This is about this graph over here. Okay, the x's have to be what? One has to tell me left and one has to tell me right. I'm gonna start with left and right. Do you get what I'm doing, guys? Okay, so x is negative over here, so left, and positive over here, right. Okay, but the y is what is the function doing? What is this function doing on the left? Down towards negative infinity, and on the right? All right. Anybody got number 2? Okay, so what are the words? What does this mean? Down on the left, and this means down as x goes right. Just kidding. All right, is that about it? Oh no, we got to do discontinuity one more time to wrap our brain back around that. What happens at -4? Is this going to work at -4? No, it's not a part of the domain, because if you put a -4 in, you'd get like -6 over 0. So this is discontinuous. Each function is continuous at the given x value, so I guess we could just write no, it's not. Is this continuous at 1? If I put in a 1, I get out 1. So I get a nice ordered pair, 1, 1. You could graph this. It's a polynomial. It's doing something like this. I have no idea. But it is continuous everywhere, so this is yes. This is the kind that we're going to talk about later. But do you see where all the rules change at -2? So if we were to try the first rule up here at -2, we'd get 2 cubed. Is that a cubed or a squared? Can anybody read that? Okay, 2 cubed would be 8. If we put in the second rule, it says no matter what you put in, you get out a -10. If you put -2 in the third rule, that would become a +4 minus 16, which might be -12 minus 1, -3. Anyway, is it the same at all of them? No. Now am I done? Yay! Okay. So tonight, can you look at worksheet 4A? I don't know. Is there more than one 4A? I so totally messed up the... Is there some practice on 4A that looks right? Okay. Can you just do, all you got to do is 1, 3, 9, and 15. It's the odds because they're numbered weird because I just randomly picked some problems and put them on that page. 1, 3, 9, and 15. Okay? What do you have to do on those? Is it right-end behavior? Oh, and the discontinuities, both, if it has one? Okay. And then there's also a delta math called 1.3 that I think is like very short, okay? The continuity problems in delta math, I think you just have to list where there's a discontinuity. And then the end behaviors, like I said, it's multiple choice, okay? There might be some end behaviors based on an equation. Does anybody remember we talked about this yesterday? What's the degree of this? The degree is the highest exponent. We talked briefly about this yesterday. If it's odd degree, both ends have to go opposite directions. Could look like that or that. If it's an even degree, like, I don't think actually that I assigned any delta math like this. Okay, the highest exponent power here is an 8. If it's an even degree, both ends go up or both ends go down. I don't think I signed that though. Okay.